Welcome to Embry-Riddle Aeronautical University, home of our SUAS team, Mission Maverick. Say hello to both our development team and our competition team pictured here. Before any development or flight operation, our team follows a set of standard safety protocols to ensure a safe working environment. All team members are required to wear appropriate personal protective equipment, including safety glasses and closed-toed shoes, when working with tools, soldering equipment, or propellers. Propellers are always removed when performing electrical or software work on the aircraft to prevent accidental motor spins. Batteries are handled with extreme care. Charging is done only with approved LiPo chargers in a fireproof container, and all battery storage follows proper voltage and temperature guidelines.
So the pre-flight battery assessment, we're checking the connections, the cables, as well as the battery itself, make sure it's not puffing. This prevents any kind of unwanted fires.
We maintain a clear and organized workspace with tools and components labeled and stored properly to avoid tripping hazards or accidental damage.
We ensure our team members all have their long hair tied back and loose clothing, and we ensure that everyone wears closed-toed shoes and long pants when working on the UAV, both in the lab and out in the field. There is a fire present in the lab or during our on-ground operations, we will contact 911 immediately and contact our advisor. In the event a battery were to spill, we will reference our battery spill kit and take necessary action to use baking soda to neutralize the battery acid. We will also reference the Embry-Riddle Environmental Safety Risk Assessment sheet and contact our advisor.
Before every flight test, a full pre-flight checklist is completed, including a mechanical inspection, firmware verification, GPS lock check, and radio connection test. Only qualified safety pilots are allowed to fly the aircraft, and all tests are conducted with a visual observer present. We also maintain a safe perimeter to keep all team members and bystanders clear of the flight area. These procedures help us reduce risk and ensure that all development and testing activities are carried out safely and responsibly.
Just like for a manned aircraft or any other drone that's out there on the market, we have a set of procedures and that we have to go through that ensures that each component is ready to go. So we check the props of the aircraft, we check the actual structure of the aircraft, make sure there's no loose bolts. We'll go through and make sure all the components are properly mounted onto the aircraft, basically ensuring that as the aircraft is airborne, nothing will come off, nothing will come loose that could risk the aircraft or the other people in the area. So throughout our testing process, we've been operating inside a caged environment. It's a net that is about 50 by 50 feet. And it allows us to get the aircraft airborne, as well as maneuver around in small spaces, while isolating the aircraft from the crew members that are on the ground. So if we have a lost link issue or any kind of problem midair, and the aircraft is going to crash, it cannot climb into the airspace and affect nearby aircraft, and it cannot crash and hit one of our personnel.
During our development process, we carried out multiple test flights to verify the aircraft's stability and system reliability. These tests allowed us to identify and address potential safety risks, helping us implement effective mitigations for safe and consistent autonomous performance, and also manual performance. For example, this is a screen recording of a past autonomous drone mission over a lacrosse field. The drone follows a series of preset waypoints, covering the area efficiently with no manual control. It was a successful test, proving the autonomous flight capabilities of our aircraft.
This segment demonstrates the manual flight capabilities of our aircraft. We begin with a manual takeoff, climbing above 50 feet AGL. Next, the aircraft manually travels to a point over 1,000 feet away from the safety pilot. After reaching the target distance, the aircraft returns and performs a manual landing. This completes a manual proof of flight for the aircraft with the safety pilot. This segment demonstrates autonomous flight of our aircraft, operated under the supervision of our advisor and our RPIC. The flight is conducted at full loaded weight. In this flight, the aircraft completes over 3 miles of autonomous travel in a single continuous flight. The aircraft then navigates through waypoints with a maximum position area of 50 feet. Additionally, the aircraft demonstrates controlled turns within a 150-foot radius while maintaining climb and descend angles within the 20-degree limit. This concludes the autonomous proof of flight for our aircraft Avinash with our RPIC flight crew and the team of Mission Maverick from Embry-Riddle Aeronautical University.